Welcome back. We will continue our discussion of geometric probability, now dealing with area. So the diameter of this target here is 80 centimeters. So all the way across this target is 80 centimeters. The diameter of the red circle here is 16 centimeters. So let me get a different color. Okay, so here we have a diameter of 16 centimeters, which means we have a radius of 8 centimeters on the red circle in the middle. Okay, so there's an arrow shot. It hits the target somewhere. So this arrow is going to definitely hit the target somewhere. But if it's equally likely to land anywhere on the target, what's the probability that it lands here in the red? Okay, so what we need is an event over a sample space. Okay, so our event is landing in the red circle. The sample space is landing somewhere on the target. Okay, so if it lands on the target, what is the probability it lands on the red part of the target? Okay, so what we need is the area of the red circle over the area of the entire target. So the area of the red circle is pi times radius squared, pi times 8 squared. The area of the entire target, pi r squared, is pi times 40 squared. Now pi over pi cancels. So we've got 8 squared over 40 squared. So that's 64 over 40 squared, 1600. Okay, so we have 64 over 1600. Now we can simplify that. 64 over 1600 is 1/25. So 1 over 25. So here it is as a fraction. Now, as a decimal, 1 divided by 25 is 0.04. And if I move that 2 spaces, I get 4%. Now, it doesn't say to leave the answer as a fraction, decimal, and percent. If it says that, then we will go ahead and write each one as part of the answer. If it only asks what is the probability, we will go ahead and put that as a fraction, 4%. Okay, now our next question uses that same target. So in that same target, each ring is 8 centimeters wide. Find the probability that an arrow lands in the black region. So if it's going to land anywhere on this target, what is the probability that it happens to land inside of one of these 2 black rings? Okay, so what we need is an event over a sample space. So the event here is a black ring. The sample space is the entire target. Okay, so for the sample space, it's pi r squared, pi 40 squared. For the black rings, we're going to have to do a little bit of work. So I've got an outer black ring here and an inner black ring here. So let's find each of those 2 separately. So the outer black ring, I can find by doing the entire target minus everything inside of that black ring. Okay, so the outer black ring, I'm going to use the entire target, which has a radius of 40, so that's pi times 40 squared, minus everything inside of that black ring. So that's here and inward. I need to subtract all of that. Now, if the black ring is 8 centimeters wide, I can just take that out of the 40 centimeter radius. So that leaves, once I get to here, only 32. So pi times 32 squared is the area that I'm subtracting to get the outer black ring. Okay, so that gets me the outer black ring. Now the inner black ring. Okay, so that would be this circle right here minus the circle right inside of it. Okay, so I've got 8, 16, 24 as a radius out to here. So pi 24 squared minus the circle immediately inside it, which is 8, 16 minus pi 16 squared. Okay, so let's do 40 squared minus 32 squared. 40 squared minus 32 squared is 576. So for this outer black ring, I have 576 pi. Plus, then for the inner black ring, 24 squared minus 16 squared is 320. So I have 320 pi. Okay, now I need to simplify, and I can simplify by combining my like terms here in the numerator. So 576 plus 320 is 896. So I have 896 pi over pi times 40 squared, which is 1600 pi. Now these pi's can cancel, and I have 896 over 1600, and that is 14 over 25. So there it is as a fraction. 14 divided by 25 is 0.56. So there it is as a decimal, which means 56% probability. So next, your dog drops its ball in the park. So here is a drawing of the park. If the ball is equally likely to be anywhere in the park, estimate the probability that the ball is in the field rather than in the woods. So in order to do probability, we need an event over a sample space. We're estimating the probability that the ball is in the field. So the event is the field. The sample space is the whole park. So that would be the field and the woods combined. Okay, now we have this park on a grid here, and we have 52 whole units here. Okay, so there's 52 squares. So the park has 52 whole units and then these partial units. So for the park, we start with the 52 that we're given there. Then we have to estimate the rest of these. Now, the way we can estimate is combining partials to be approximately a whole. So this is just an estimate. These two right here approximately make one whole square unit. So we've got +1 for these two. Now this right here, if I take this little one right here and spread it into these two, I think I'll get 1 unit there. So there's plus another unit. Okay, then if I take these two and put them together, that's about 1 more. If I put this and this together, that's about 1 more. And then this plus this is about 1 more. Okay, so that is 52 plus 1, 2, 3, 4, 5. So that is a total of 57. But I think I actually made a mistake here. When I took these two and combined it with this, I think I counted that as 1, but that should have been 2. So I've got these two right here combined with this one to make 2 units. So I've got 52 plus 2 is 54, 55, 56, 57, 58. So I've got approximately 58 square units as the entire park. Now the event is the field, and the field is this down here. That is 1, 2, 3 units by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So the field is a rectangle that is 3 by 10. So its area is 3 times 10. So we've got 30 over 58. Okay, so 30 over 58, as a decimal is 0.517, which means there's a 51.7% probability that the ball is in the field. What is the probability that the ball is in the woods? So our event over sample space is now woods over the entire park. So the area of the woods is the entire park minus what we have as the field. So it would be the 58, that is the entire park, minus 30, that is the field. That will leave us with the woods. And the sample space is the entire park, 58. Okay, so that's 28 over 58. Okay, so 28 divided by 58 is 0.483, which is 48.3%. Now notice if I was to add the probability that it's in the field plus the probability that it's in the woods, those will actually add up to make 100% because it covers 100% of the park. One more probability problem here. Okay, so we're going to be looking for an event over a sample space. You hit a golf ball and it hits the green. You win a prize if you happen to get a hole-in-one. Okay, so you've got a circular green, so the green is circular. You hit a ball, and it definitely lands somewhere on that green. Now, the cup that you're trying to get this in is a circle, and it has a diameter of 4.25 inches. The green is a circle with a diameter of 75 feet. The ball is equally likely to stop anywhere on this green. What is the probability that you win a prize? And in order to win a prize, you have to get the ball in the hole in one shot. Okay, so the event is getting the ball in the hole. Okay, so we'll say it's a hole-in-one. That is the event. The sample space is that the ball could land anywhere on the green. Okay, so we need the area of our target here over the area of the entire green. Okay, so the area of the hole, the surface area of that hole is pi times the radius squared. Now, the radius is only halfway across, so that's 4.25 divided by 2. The radius is 2.125. 2.125 inches. So it's pi 2.125 squared. Over, now the radius of the green is 75 divided by 2, which is 37.5, but that's in feet. I need to multiply that by 12 to get it into inches, and it is 450 inches. So the area of the green is pi times 450 squared, and now they are in the same units. Now the pi's will cancel, so I have 2.125 squared, and that is 4.51, so I'll just go ahead and use all of that. 515,625. And then 450 squared is 202,500. Okay, so as a fraction, I now have 4.515625 over 202,500. So that is 0 point and then 1, 2, 3, 4 zeros. So 0.0000 22299. So the probability of getting a hole-in-one if you can land it on the green, which, by the way, is not really a certainty in real life. If you've ever golfed, you know you are not certain to get the ball on the green every time. But if you are certain to get the ball on the green, the probability that it will end up in the cup is 0. And I'll move this 2 places, 0.02299%.